We just want to do 2 additional problems to determine molar and molecular mass of the solute. Yesterday we did them from freezing point of solution, and I just want to make sure that you feel comfortable doing it from boiling point of solution. So in these problems, you will be given information about the boiling point. You'll be given information about the mass of the solute, and you'll be given information about the mass of the solvent. And you will be asked to determine the molar or the molecular mass of the solute. And that finishes up our chapter on solutions. The difference yesterday was that I gave you freezing point of the solution. So I just want to make sure that you can do it with the boiling point of solution. In terms of question 3, they tell you have 140 grams of a non-volatile molecular substance. That tells you the mass of the solute, not what the solute is, and that I is 1 because you have a non-electrolyte or a non-volatile substance. It's dissolved in 658 grams of nitrobenzene, and that will be the mass of your solvent. So the givens I typically do in green. The solution begins to boil at 221.25 degrees Celsius. And again, same goal, to find the molar or molecular mass of the solute. So that's what's given, what we want to know. The boiling point of the solution is what? 221.25 degrees Celsius. The mass of the solute is 140 grams, and the mass of the solvent is 658 grams, and our solvent is nitrobenzene. Our goal from this information is to determine the molar or molecular mass of the solute in grams per mole. Other information that you can get out right away that may be helpful to you: in regard to your solvent, you can get your boiling point and you can get your molar boiling point constant. And where would you get those from? From the back of the periodic table. You would look up your solvent, which is nitrobenzene. It boils at 210.8 degrees Celsius, so it may be helpful to you to pull that information out at the beginning. The molar boiling point constant is 5.24 degrees Celsius kilograms over moles, or degrees Celsius per molar, whatever's easier for you. And at this point, you're going to process it grossly similarly to the way that you did from the freezing point data that we used yesterday. In the first step, you need to calculate delta TB. The only difference here is that you will be doing the boiling point of the solution minus the boiling point of the solvent, because we know that the boiling point of the solution is elevated when you add solute to solvent. If you can't remember what to subtract from what, again, delta TB must have a positive value. It's a positive quantity. So just do the larger boiling point minus the smaller one. So you've got 221.25 degrees Celsius minus 210.8 degrees Celsius. And again, when you add or subtract, you go to the least number of decimal places, as we talked about the second week of school. And you have 10.5 0.4 degrees Celsius as your delta TB. So that's one difference between what we did yesterday and what we're doing today. In the second step, you're going to calculate the molality by dividing the change in boiling point by the KB. So the only difference here are the B's instead of the F's that we had yesterday. Again, you're always using a quantity from your previous step. So the steps are sequential. Be careful there. And as we talked about the other day, what is 1 divided by 1/3? 3. So your unit here is 1 over kilograms per mole. So your units moles over kilograms, or molal for molality. You have 10.4 divided by 5.24. And that is 1.98 moles per kilogram, or molal. So that's the second step, grossly similar to what you saw yesterday. You're just using boiling point information instead of freezing point. In the next step, we're going to calculate moles of solute as we did the other day. If a mistake's going to be made, it's going to be made here. It's molality times the mass of the solvent in kilograms. We have the molality from the previous step. And the mass of the solvent in kilograms. So again, they give you the mass of the solvent in grams. Move the decimal 3 to the left, or divide by 1,000. Kilograms cancel. You have 1.98 times 0.658. And this is 1.30 moles of solute. And how would we determine the molar or molecular mass of the solute? We know our unit is grams per mole. The moles are right here. And what mass do we enter in the numerator? Solute or solvent? Gotta be solute. So I have 140 divided by 1.3, and that is equal to 108 grams per mole. And again, grossly similar to what you did yesterday. I'm going to let you try number 4. I just want to help you pull the information out. It's ever so slightly different. It's actually easier. I just want you to see the wording so that you can understand how to approach it. I don't think I would have given you one like this, but I've seen it on other types of exams, so I wanted you to have exposure to it. In number 4, you have 187 grams of a non-electrolyte. Solute or solvent? That's the mass of the solute. It's dissolved in 692 grams of cyclohexane. That is the mass of the solvent. It says the boiling point is raised by. What does that 25 degrees Celsius represent? Is it the boiling point of the solution, the solvent, or the change in the boiling point? It's the change. So in this particular problem, you don't have to do step A because it's already been done for you. Delta TB here is 25 degrees Celsius. So we'll set this one up and you can give it a shot. The mass of the solute here is 187 grams. The mass of the solvent is 692 grams of cyclohexane. And again, you need to know what your solvent is to get its TB and KB. The boiling point is raised by, so they're giving you delta TB, which means you can skip the first step, and the goal, as it's been all along, is to determine the molar or molecular mass of the solute. So I'm going to have you try this problem. I'll reveal the answer on the screen for the kids who are out. Don't peek at it so that you get a good feel as to whether you understand it. And for the rest of class, you want to work on this one. And in addition, what you absolutely want to get done prior to your next class on your classwork would be numbers 26 through 29, all on molar or molecular mass determination. So we have all our variables listed. And again, you don't need to do step A because the delta TB has been provided for you. It's 25 degrees Celsius. It may be helpful to get the KB of cyclohexane right away, 2.75 degrees Celsius per molal, or degrees Celsius kilograms per moles. And the boiling point of the solvent, cyclohexane, is not needed because they told you that the boiling point was being elevated or raised by 25 degrees Celsius, so you already have the delta TB. I'd like you to try and give this problem a try. I will reveal the answer just so you can check your work. But I also want to tell you what classwork problems go with this molar or molecular mass determination from either information about freezing or boiling. And so the classwork that you can do that corresponds with this section is shown right here. These will be the molar or molecular mass determinations. Again, remember, numbers 15 through 19 should be complete already. You do not need to do questions 20 through 25 unless you have an interest there, and I'd be happy to go over that type of problem solving with you. When you work through number 4, you'll check your answer, which is shown here, and you can have the rest of the period to work on the classwork in an effort to better understand colligative properties and molar and molecular mass determination of solute. We will get into the lab when we return from break, and we'll generate solubility curves, and everything will fit into our overarching learning goal that we've been talking about for this chapter. And so this is what you want to be comfortable with when you return from break. And again, in case you need to go back and look at number 4, the answer is shown here. All the worked out answers for your classwork are posted on Edline, and you should be checking through that as you go to make sure that you understand. Make sure you get all your classwork done over break so that when you sit down to study for the test, you're truly reviewing and not trying to put the pieces together for the first time. Super, have a great break, and we will see you when we return.